In this video, we're going to learn to multiply a matrix by a scalar. A scalar is just a single number. It's not an ordered pair, it's not a matrix, it's just a number. And can we multiply a matrix by a scalar? And yes, we do define a way of doing that, and that's to multiply the scalar by each element in the matrix. So this would become 10, 15, negative 40, 5, 30, and 20. And there we've taken a matrix times a scalar, and that gives a new matrix. This is 2 by 3, and so this one will also be 2 by 3, but now each number has been multiplied by 5. It's similar to a giant distributive property where we've had parentheses in the past, but now we're using it to multiply a scalar times a matrix. Let me give you two to see if you can do them. We'll multiply that one by negative 3. We'll multiply that one by 6. I'll give you a minute to do them. Hit pause, then you can come back and check. Okay, this is negative 12, negative 3, negative 27. And this one is 30, 0, and 6. Now let's combine adding and subtracting, multiplying by scalars with matrices all together in one expression. Let's let A be the matrix 2, 5. We'll have B equal to 6, negative 2. And we'll let C equal 0, 8. Now we can write expressions such as 2A plus B minus C. And what will that equal? Well, first we start with 2A. This would be 2 times 2, 5. That would give us 4, 10. And that's added to B, which is 6, negative 2. And then we're subtracting C, which is 0, 8. So it'd be 4 plus 6 is 10. Minus 0 is 10. And 10 plus negative 2 is 8. Minus 8 is 0. And so that's how we can have expressions built using matrices. I'm using simple matrices simply to save us a lot of time and writing on the board. Let's see if you can do this one. 4A minus 1/2 B plus 3C. Plus pause, take some time to work it out, and then come back to see if you did it correctly. Okay, this would be 4 times A, so 4 times 2 is 8, 4 times 5 is 20, minus half of B, so half of 6 is 3, half of negative 2 is negative 1, plus 3 times C, 3 times 0 is 0, 3 times 8 is 24. Now we add them together. 8 minus 3 is 5, plus 0 is 5. 20 minus a negative 1 is 21, plus 24 gives me 45. And that's how we can calculate expressions built on matrices. Of course, that leads us to, what about solving equations with matrices? Can we have equations that are built of matrices? Yes, let's try this one. X plus A equals B, and A equals 2, 1, 6, 3, and B equals 4, 5, 8, 2. Well, we would solve it like we would an equation. Cancel A and bring it to the other side. X equals B minus A. So then I would calculate B is 4, 8, 5, 2 minus A, which is 2, 1, 6, 3. And so X matrix is 4 minus 2 is 2, 8 minus 1 is 7, 5 minus 6 is -1, 2 minus 3 is -1. And there you have a matrix equation and how I would solve it. Let's try one a little bit more complicated. Let's try this one. B is equal to 2x plus 3a. Okay. In solving this one, I would first cancel the 3a. And so I have b minus 3a equals 2x. Now we'll divide by 2, which means that this would be written in parentheses multiplied by 1/2. So we'll change it to a multiplication problem. Cancel that. Now to calculate x, we'll have 1/2 of b, which is 4, 8, 5, 2, minus 3a. And 3a means to take a and multiply each element by 3. So that'd be 6, 3, 18, and 9. So I'd have 1/2 of the matrix. 4 minus 6 is -2. 5 minus 18 is -13. 8 minus 3 is 5. 2 minus 9 is -7. And so that would equal 1/2 of -2 is -1. This is -13 over 2. This would be 5 over 2. And this would be -7 over 2. And so we were able to solve the equation for x. This gives you an understanding that matrices then develop a whole different number system which follows a lot of the same rules as we know with real numbers. The advantage of using matrices is matrices can be used to apply to multiple numbers simultaneously, such as in computer gaming, they will have a matrix which represents maybe power and strength and hit and all the different aspects of a particular weapon. And then when it's fired, they can add that matrix to whatever it hits or whatever hits you. And so they are able to accomplish a lot of different things simultaneously by the use of matrices, which divides numbers up into different locations and categories.